Okay. So in the last lecture, we have talked about different components, or we started a journey looking into the enterprise and how the hierarchy from the designation point of view can be laid out in a company, and what are the IT infrastructure and what components and how it all evolved, like from the 100 years ago. Today, we will touch base upon an important topic. So far, we have been talking about the hardware side of the world. Infrastructure, within the infrastructure, we have only discussed about the hardware side. Whether we have talked about data center or we have also talked about the virtualization. Both of them is to virtualization is to splitting your hardware and creating a virtual environment which is as good as your physical hardware. But today we'll talk about a software. And anytime, what in my opinion, anytime we bring this topic of software, the most important concept that everyone should know and they should understand about open source. So open source has a very good, significant, and open source has actually played a very good role in the IT ever since it was actually founded. And we'll look into the open source, the history of the open source as well. There are so many companies today which are billion dollar, even they're probably going to touch the $1 trillion as well, based on the open source product. The very good example for company that have actually made a lot of money or a lot of success, I would say, it's Google. And there is another one that we want to keep an eye on. It's HashiCorp. HashiCorp is also a very good example, a very recent example that is actually coming onto the scene, and they have even sustained, they have resisted the Google as well. Google wanted to acquire them, but that couldn't happen. And HashiCorp is the team, the company also evolving, and they have a lot of product which is open source as well as the enterprise. So you'll get a good sense of the how starting with the open source, how it's going to benefit. But first, let's talk about what is open source. So source in this part, or at least in this is within the open source, the part of the source is actually has a reference to the code, and we're talking about code source or source code, right? We generally say this way. Source code is nothing but a program that we write. Every program that we are writing, it's qualified, and it can be called as a source code for whatever the application or product that has been built. Everything that we see in the digital world, everything that we interact with, whether it's your mobile devices, your car application, your operating system on your laptop, the paints that we are using right now, the Zoom that we are connected with, everything in the digital has, this is a program and there is a source code behind it. And source code is going to act like a secret recipe. So your source code is your secret recipe. And do you want to share it with the rest of the world? It's up to you, because they're going to copy that. And in the digital community, actually, there is a very good history about it. So we'll talk about that, and then you'll get an answer to the question. How do you prevent from somebody copying your secret recipe? So it's a very open world of the IT, and it's a sharing, caring sort of concept. The more you share, the more you grow, the better you will get. So education can, if you spread the education, it will only gonna increase. It won't decrease. It's not like some physical stuff that you have. So if you start distributing to the people, then you're gonna end up losing everything. It'll reduce. That's not the case with the education. And source code is being considered or thought of, it's kind of an education that you are providing, because you have applied some logic, you have a way of your way of looking at that particular problem, because we develop application, we developed all of these tools and whatnot. It's because we want to tackle some kind of a problem, right? And so you have your own view or your own approach to to looking or going about that problem, and how do you solve that with the application that you have written. It's all hidden in your source code, right? So every program, everything that we interact with in this today, in this era or in this generation, there is a source code or program behind it. So back in the day, not so long ago, like 50 years ago or 60 years ago, or at least before 1980, the proprietorship was only on the hardware, right? Before 1980, so I'm gonna write an era before 1980. It was only the hardware which was proprietary, and we know the hardware manufacturing company, right? Last time we did talk about those, the company who manufacture the hardwares, or the company who's thought to be the leader or who has been doing it for a very long time. It's IBM. So any hardware that you are creating, that hardware has the proprietorship, and you basically have a copyright on your hardware, so nobody can copy whatever the model or design that you have made. And you put copyright for that purpose, that nobody should be copying it. So before 1980, everything, all the source code for any application was, there was no copyright on them. So if you buy a product, if you buy application, you could also see the source code, how it is being developed. Today we are using, I'm using Windows, you are using Mac probably. As long as you're not using Linux, even within the Linux, there are, the enterprise Linux are also available. So if you are using enterprise side, then you don't get to see the source code. I cannot see the source code of the paint, how this is written and how it's actually functioning, what Microsoft have written in the bracket. I mean, there are similar applications available, but at least for this application, which I'm using right now, I may have paid for it. I still can't see the source code, how they have, how they have developed it. So it is right now copyright, and I cannot tweak it. I mean, I can, get to the bottom of that, do reverse engineering and this, that, but that's going to take an awful lot for me to get to a point where I can see what is it. And then again, it's a copyright, so I cannot tweak that and then start selling it, because if I do, I can be sued, and then I'll be liable to pay whatever the fine, whatever the fine they would do that for the lawsuit. So before 1980, it was only on the hardware where you had copyright. You didn't have that on the software. There was an incident happened during that time, and we all know around 1980 or 81, Apple came, and Apple home computer, right? Apple 1 was introduced, and then a few years later, 1982, so somewhere around that, Apple 2 was also there. So Apple 2 was released, and there was this company called Franklin Computers, and when they actually released their Apple II, Franklin Computers created, they created a clone. Clone of Apple II, and they simply said Franklin, whatever name, they said it is 1000. And Apple was not very happy about that, because they copied everything, whatever they had it, and they started selling. And they, because it was the clone of whatever Apple II had, that was all because the source code was not copyrighted, and anybody could see the source code. There was no copyright on that, on the source code. So you buy it, you can just dissect it, you go and do the postmortem sort of stuff on that, and then you come up with your own version of the the application. And that's what happened with this one. So Apple was not very they were not very happy about that. They went into the law. They had there was a lawsuit that Apple and Franklin Computers had, and Apple ended up winning that lawsuit. And from there on, there was an amendment, in the law was, from that point of time, a law was made that from the 1983 onwards, even the hardwares, even the software will have the copyright. Now, this means that nobody can see the source code of the software if they buy one. And around, so now previously, it's not like everybody can go and look at the source code. And at the same time, it was not the time where everybody has a very easy access to these devices as well. I mean, in the early 1980s, it was very difficult. Apple made it easy, but still, they made it easy. They made it portable, and so at least common people can afford. But it was still not very common that everybody would have that in their home. It would still take few years from now before that's a scenario. So you don't have a lot of people, a normal people that could do that. The people who would want to go and see what is this software about, how it's written, in what language it is written, does that make sense to me or not. Mostly it was the college or university students who are doing a lot of research and who have worked on different application, or they have some references from the past. They were the one who actually would do something, and they actually cared about the source code, but the rest of the world is fine. I don't know, I don't understand, I don't want to look into that. Even to this date, there are maybe out of 8 billion population that we have, probably 6 point, just a 1 or 2% of the people who would understand the source code. Not the rest of the population. They don't care, they don't understand, and they don't even care about that. If you make it easy, user friendly for them, then you have yourself saved. Otherwise, nobody's gonna buy whatever you are doing, because as and that was the whole idea the Steve Jobs had. They wanted to make it as user friendly as possible, because before that it was all terminal. The black and white stuff used to intimidate people, and they brought the graphics, and they tried to make as user friendly as possible with whatever available the resources. The limitation on the resources was there at the time. They did it the best, and Windows came in around that time as well, and they were started competing in the graphic stuff. So around this time, there is this guy called Richard Stallman, and and you want to remember his name because he's considered to be the father of the free software movement, or open source, what we have right now. So he was one of the brilliant students of the university, and he used to work for the university as well. And there was one incident he encountered where universities, they used to use printer, and there was this application that actually was responsible for doing the printing, and they were running that application on a schedule which it used to print in every night. But sometimes printer gets stuck, and the printing would complete, and then they find out in the morning, okay, all the printing that's supposed to happen during the night time, that didn't happen, and now they have to engage the resources of printer and other application from which they are actually doing the printing. So he looked into the application which was actually doing the printing, and he fixed the application. Basically, he tweaked the code. And since he was a student who understand the source code of the application, he went ahead and he was able to do that. But after 1983, that was not the case, and he was very pissed about it, because he was like, okay, I've paid already, and all the research and everything that are happening from the most of the time. First, I pay for the software. Second, all the research and developments mostly are happening from the government agencies, or either happening in the universities. And all of these entities are running by us, because we are the taxpayer. We are paying the tax. We pay the tax, we buy the software. Still, I can't see the source code. I mean, this is my property. Once I buy it, I should be able to see that. And this is where a movement started for the free software. And Richard Stallman created a movement under the banner of GNU. GNU is a recursive. GNU is the recursive. I mean, it stands for a recursive. It's a recursive abbreviation where every time G stands for GNU, you simply call it GNU, and N and U has a meaningful. So GNU stands for Gnu Not Unix, right? And every time you do that, so that's a clever programmer, or a very geeky guy would come up with that. So you have a lot of actually acronyms within the IT that are very recursive, because first letter means that letter itself. You have so many things where you'll find so many instances, so many names where the first letter itself, it's the same thing. So today we have something called YAML as well. So this stands for YAML Int Markup Language. So the first Y stands for YAML, right? So it is it has become, so this is Y, this is int, this is markup, this is YAML. So so YAML stands for YAML. So this is also a recursive full form, right? Very common that we will end up using it. And there are so many others as well. You'll find a lot of references, a lot of different ways where they have a recursive full forms. So Richard Stallman came up with the GNU movement, where he created a lot of software. And because Unix, the operating system, the dominant operating system at the time, where everybody was using it, we'll see about that history as well in a moment. But Richard even that source code was not available, and the application would run on those Unix system. Those application source code was also not available. So he simply called it GNU, which means GNU Not Unix, and it is the you can see on the internet the symbol of that as well. It's a bison sign that he uses with. So around 1983, he started that movement, and in 1987, he was able to form a foundation called Free Software Movement under the license, which is called GPL, GNU Public License. He was a software foundation. Ignore the typo with that. And so here free means free as in freedom. It's not a free which is free of cost, because copyright holders grants user to it grant user a right to use, study, change, and distribute, and further distribute as well. So that's what these open source license would do that. Because of these open source license, we have the IT community have grown, and we have so many applications that are available today. Company like HashiCorp is the very good example, because that's a company you're probably going to be interacting as well, because I'm assuming everybody here are from the sysadmin background, or which is, you're not from the development background. If you're not a developer, then you go to the other side of the world, which is the sysadmin world, where you could be a DevOps, you could be a SRE, you could be some kind of a platform admin, you could be cloud admin. So if you are that, then you're gonna hear HashiCorp company a lot, because they have so many products, and everything that they are doing is for the sysadmins. And HashiCorp has actually created everything from the open source. So open source, if you do that, I mean, even if you were to develop something today, there are so many things that you could do with the open source. Benefits point of view, if you develop an application, you're going to need a creative person in your team, a creative developer, or a person who can do very groundbreaking inventions, or he could do some very different sort of development, which is very hard to find. I mean, at first, finding a right skillful people, it's very rare. And then on top of that, you are supposed to find a people who's very creative, who can do some groundbreaking inventions for you. That is next to impossible, right? If you start hunting it down, that becomes very difficult. And when you do something, when you create open source and you publish it on the platform, there are so many platforms available to this date, and we'll talk about that. So if you create anything open source and you publish that on the platform under the license, whatever the license have a lot of terms and conditions, and to summarize that, the license will give you a right to use, study, change, and distribute the application further if you want. And so coming back to the benefit with the open source, you create an application, you open source it. The other people, if they come, I mean, whatever you are creating an application, you're basically again creating it to solve some kind of a challenge. So if you have faced a challenge and another person also faced the challenge, he would, if somebody is actually doing something on the open source, which means he is a different person, because how often you come across a person who has done a lot of contribution to the open source project. That is very rare scenario that you will come across people who have done that, because those people are very rare, right? Amongst the 1 or 2% that IT people are there in the world, out of that, you're probably gonna find maybe another 1 or 2% who are actually doing some contribution to the open source project. So first, when you publish it, you find whoever is going to contribute to that open source project, he's creative. Second, it gives a lot of marketing or publicity, because all the big companies and even the people who are not contributing, they still keep an eye on the open source projects. They see, okay, what is going on in the market, what type of tool people are coming up with, what is the creativity amongst the IT people. So they keep an eye, everybody subscribe to the newsletter. So you publish it, you don't have to spend a lot of money to the marketing, because as soon as you do that, everybody's going to get alert that, you know, a new project has come in. We'll talk about, we'll not talk about in detail like how you can go about, you know, open source your project. But there are few terms when you know, you would want to know within the open source that are very commonly used. So those are the benefits are there. Once you know the lot of people, and then from people a company will start using your open source product as well. And companies, like I say this again and again, no company is created to do a lot of changes. So if any no company is running because they want to do some changes within the products that they're using. Companies are like, okay, this software or this application is working very good for me, I don't want to change, because change is very expensive. Change can you know, create a havoc in my business can stuck as well, because when I do the changes, there are high chances that application may not behave similarly. Like if I'm running some website and then I upgrade the website, user, you know, may find a bug. There might be something that user can report, and it's not a very good for the business that somebody is complaining about the product, right? So it can be buggy. It can you know, sometimes it won't go very well on the hardware, because applications are running on the hardware. So many issues are there, and you're not, as an organization, you're not gaining anything. You're just investing, or you're investing a lot of resources for nothing. So no company is created because they want to do a lot of changes. Why I'm bringing up this here right now? Because if people started using the product, or companies started using your open source product, they'll get a hang of it, and they don't want to change that. Okay, I'm using this one you know, for last 2-3 years, it's working quite well for me. But the problem is, it is open source. If I run into any issues, who's going to resolve the issue for me, right? Because the open source community can do that. But the problem with the open source community is they're not bound to work for whenever I have the issue. I have to wait like days and days before somebody feels like, okay, maybe I should go and answer it, because I know that. So there is no guarantee when you're going to get an answer to your question when you post it on the open source platform. I mean, you can post your question on Stack, on GitHub, or you know, there's a few more platforms available. But you don't have any assurity when people gonna get back to you and they'll answer you. I mean, if that application is open source on some open source platform, like I'll give you a few names. You do that anywhere, nobody is bound to actually work on your dedicated hours. So when you grow as a company, you won't want some assurity. Okay, this application goes down, where do I go? So what you can do now, because you are the copyright holder, I mean, you have all the rights. You have just given a people to only use it and study and change it. What you can do now, you can come up with the enterprise version of that your product, where you say, okay, you know, because I am the manufacturer, or I am the one who actually built the software, or my company is the one who built it. Now I can also I've started giving you a support as well. So anything goes down, you call me. I have expert people who actually developed, or they have manufactured, or they have actually built it from the ground up. They know in and out of the application. They can fix your issue in no time, just like that. So companies would go for a support now, because that is needed. They would rather go for a support than changing it, and then, you know, they change it, they take a new application, and they run into same issue again. What if something goes wrong there as well? So you have a double effort now. First, you waste a lot of effort and money and energy to upgrade or change whatever you are using, and then after using that, you have to pay for the support as well, because it's the same scenario there. So once people get used to it, you have a very good chance of making it a enterprise where you can provide the support. And this is exactly the model of the HashiCorp. This is what they did. First, they published, they made all their application open source. People started using it. Everybody got the hang of it. You know, they got addicted. And then they said, okay, now we have the support as well. If you guys want, you know, you can sign up for the enterprise. We'll give you all kind of support, because we are the one who built it. So we are technically the expert of this, right? And so that's, and they've become a company that is competing with a lot of other company or settled company. The HashiCorp is the company who came, you know, I think they were founded in somewhere around 2012 or some 2013. I mean, they had it registered, but before they published, it was 2014, so not so long ago. I mean, if we talk about history, it was just like yesterday. They came up, but they've grown up to be a very big company that they are able to resist the temptation from the big sharks, right? All these big sharks, like the big company, they want to acquire them, but they are sustaining or they are resisting it. So that's a benefit of the open source. Now, as a part of GNU, what they had is bunch of software. So many software, that were, if you want to write, you can write it under this license, so your application is not abused, and you could take some legal action against whoever is doing that. So you could do that. Application, the grep, emac, and tar, all these, the few, to name the few software which was part of the free software or GNU, under the GNU, and there was others as well. So they did not have any kind of operating system. They were just had this platform for the open source, where if you want to write an application, you write it under our license GPL, and we protect you from getting abused or misusing your application. That's what they did. So today we have so many different platforms. The most common or famous is Apache Foundation. You hear a lot of I don't know if you have heard, if you have worked with application, you might have heard a lot of time the word Apache. So Apache is also a very famous platform where a lot of open source applications are hosted and published. So it is one of the platforms. So it's Apache Software Foundation, ASF, which is very common, and there are a lot of projects, or a lot of projects are available on this platform. The one, if you are, like I said, if you're from the sysadmin, even if you're not from the sysadmin, what we have today is cloud. What's the thing that driving everybody is crazy, that everybody want to go to? It's cloud. And all the cloud related products or the projects are hosted on a site called CNCF. Cloud computing, cloud native foundation, right? Cloud native, something with a C, which I don't remember. So we have that. I'll show you. We'll go and look at the site as well. So one thing you need to know, whenever the new project comes in, there are few terms that are there, and the terms are like equally same on if you go on any platform, whether you go on free or you go on Apache or you go on CNCF. And then there are country specific, the platform or foundations are also available for a free software, right? And it has grown to be a very massive or a very wide range of varieties within the different. MIT has one. So there are so many platforms available today, but the one we should keep an eye or watch out is the CNCF. And you go for any platform, there are few terms that you want to remember. So anytime a new project comes, the new project needs to be in the sandbox. So sandbox, you might have heard about the sandbox, which is a sandbox environment. Create a sandbox server, sandbox this, sandbox that. You hear a lot in the IT, people talk about that. So whenever a new projects, you want to host a new project or new projects comes in, that project has to come in the sandbox first, where it is under the development, where you do a lot of trials and error, you create a POC, you create MVP, all sort of different stuff, prototyping and other. And after the sandbox, your application gets into the next stage, which is called incubating, where it's where you have it. Your application is promoted to the next stage. After incubating, basically it goes to production, and on open source we call them graduate. So the application will be graduated, and once like nobody is available, some applications survive and some go on to be a big application that is there forever. Because one thing in IT, that in every few years, or in my opinion, in every 4 or 5 years, application will be legacy, right? Like the term that I used last time, the cutting edge of today is the legacy of tomorrow. That's what happens here. So you have your application which is being used by everyone and everywhere, but that application gonna run out of its course. It will someday it won't be as hot as it was at some at some point of time. So your application will be graduated, and then when that happens down the line, your application gets retired, or whatever the project you have. So it gets retired or it gets archived. So these are the few terms that you want to remember whenever the new project comes in. And having this sort of understanding is only going to elevate your status when you talk about somebody who's there in the IT. Because what I am seeing, I mean, forget about people who are contributing to the open source community. There are people who don't even know what is the open source. They are working in the IT, but they don't know these terms. I mean, these are the terms. If you put stuff like that on your CV, the chances of landing a job becomes very high. I mean, stuff that you have contributed to some open source project, that those sort of stuff. If you look into the CV of the Bill Gates, it was hardly a half page where he mentioned about that he worked on 2 open source projects, this, and that was his CV. And if you do that sort of stuff on your resume, the chances will become very high for you to get a job, right? So maybe that's a far-fetched idea for us right now, but at least having a good understanding of how this community works, and you can always keep an eye, and you can bring this in your conversation. That will sound you, it'll sound a very mature or fine-tuned, and you'll have a good reputation, in my opinion, because that's not like every other person is using nowadays. So let's head over and see one of the project, and what is the source code that we're talking about, and what is this stuff. So you can go onto the wiki, and you're probably gonna find a lot of one. A wiki is a very good source where we can see, it's a library, and if you want to see the different foundations that are available, I would recommend to go and check that out. But let's go to CNCF. My browser is visible, right? Can somebody give me a thumbs up to confirm the browser is visible? Right. Okay. Thank you, Victor. Okay. So CNCF is Cloud Native Computing Foundation. So let's head over to this site, and so here we are, and all the projects will be gonna be here. So we have the community, they run the events, right? They have the meetups, summits, the blogs. They write a lot of blogs as well, which you can, all of these are contributors. So these are community, open source community, and it's made up by the people who are willing, who has a willingness to contribute to the good cause. And it's a win-win situation if you do that. I mean, it's going to elevate your status amongst the average people, and then you're doing something good for the community as well. You take a lot, but when you start contributing, it's time to give to the community as well. So if we look into under the projects, and you go to any foundation site, you're going to find a more or less similar stuff, right? So here are the projects. So we have the sandbox, the archived, which are retired right now, the graduated and incubating ones, the ones that are graduated or promoted to be used, and the ones it's going to be ready to be used. And then we have sandbox as well. So let's take a look into the sandbox, what projects we have at this moment. So, okay, let me accept this. So all of these are available, right? These are the ones that are available right now. If you subscribe to the newsletter, you'll get an email about everything every time there's something new has come up. So you have all of these, different, most of them, normally will be written with the open most of the time, because it's open source. So that generally shows it's, has something to do with the open source, if you have with the open source as well. So there are so many here. Maybe let me pick one of the. Let's go and see the source code of this application. So if we go to that, you're gonna find a further information about that, like all the different social media links. Here are the the other links we have. We can go to the website, because they happen to have a website here as well. I mean, still is in incubating. Sorry, this is in sandbox. It's not even incubating. On the GitHub, so GitHub is, we know that GitHub is one of the platforms where you can store the codes, right? So all your source code can be hosted here. So if I were to click, I hope I would be taken to a link, where the source code is available. So we are here on the GitHub, where the whole source code, the recipe is available here for everyone to see. And these are the contributors. So there are like 160 people who are contributing to this one, and there are contributing guide as well. I mean, no, you can't just go and do any the way you like it. There is a guideline which you have to follow, and plus the programming language, right? So mostly it's a thing of the developers, and sadly, we are from the sysadmin side, and sysadmins are not a very good developer, and they don't understand the programming language, or especially the object-oriented programming language. And if you want to contribute to something like this, all the groundbreaking inventions or stuff like that are happening in the object-oriented language. So if you know the language, it's good. And here is where you can see that. So this is the way how GitHub is reporting its status. If you were to go and see on the GitLab or some other platform, you're probably going to find it in some different look or feel, right? The UI is going to be a little different, but more or less you will find these sort of information. So this particular application is 97% written in Java, and there are some usage of shell, which is a shell script, something we will see later as well. And then a few things of the others as well, like Groovy and Makefile and Dockerfile and stuff. So that's that's how if you do that on something on the open source, and CNCF is where you want to keep an eye on, because here all the cloud native stuffs are happening, and everything that we are using on the cloud, those sort of stuff are actually taking place here as well, or hosted here. So let me get rid of that. Let's close it. Okay, so so this GNU movement, when it came, this is all about software, right? Everything that we have seen so far, it's a software. So this software needs to be run somewhere, and that is hardware. But can we run the software directly on the hardware? No, we cannot. We need a special kind of a software, which we call operating system. We actually don't need an operating system. Actually, we need a kernel who can talk to the hardware. Operating system is made up of these things. Operating system or operating systems are made up of kernel. We'll see about what is the kernel, and softwares, and then there are software manager and desktop UI and other stuff. So desktop, these stuff gonna make up for the operating system, and the software, this part, right? It's available here with the GNU. So we've got a free software, right? We are one step from actually, so we don't need this to actually, we just need the, these are just the inventions, later, which has come now, but all you need is the kernel, and you need bunch of software to create operating system, right? So we do have a free software under the banner of GNU. There are a lot of software available, and I've just written a few names, which we use, and because people started contributing, so many software are available now here. But what is the missing piece here is the kernel. We do not have the kernel, and kernel plus software is going to make up for your operating system, and it's mainly the kernel is actually going to make up for your operating system, because kernel is the guy who's actually gonna who will be talking to the hardware. Kernel is the one who will do the communication to your hardware, and whatever the hardware that are connected, you can operate with the software with the help of kernel. So kernel is like a door, right? So door that will connect you to inside some other house, which is a hardware for us right now. So you can imagine like a shop. You have a shop running, and they have a warehouse in the backside, and on the shop they are able to showcase all the pieces or samples, and if any order comes in, they always go back and get those ones. So the door from which you are going back to the warehouse, that is the kernel. That's exactly what kernel is going to do, that because everything that we see on the software, like I'm playing a video, right, and I want to increase the volume. That volume, when I increase the volume, basically that will there is a sound, right? Sound card is there, and the speaker is there. So these are the hardware. Now when I increase the volume here on my video player, the kernel is the ones who's actually giving the instruction to your hardware to raise your volume and make a loud sound, right? That's a kernel's job. So anything that we do, kernel, without kernel, we cannot interact. So the missing piece right now to form a software is the kernel, and we'll talk about that. So like Richard Stallman is considered to be the father of the free software movement. We'll talk about the mother of operating system, right? So it's so I mean, just because these are the term, I'm not actually trying to tie a relation here. Like I call this guy a father and this guy a mother, but there is a mother of operating system, right? And if you have guessed it, if you know the name, then that's good. If you don't know, then let me write it down here. So mother of operating system is the Unix, and all the operating system that we have today is actually coming from the Unix. Okay, so there is a bit of history. Before Unix, actually we had something else, and the AT&T lab is gonna come a lot if you are into the IT, or especially if you are into a programming and you are learning the languages like C and C++. So those are the ones actually coming out of the AT&T labs by the two people named Ken Thompson and Dennis Ritchie. So in 1964, AT&T lab started a project called Multi-CS. I forgot the full form of this, but that's not important right now. So we started the project, and this was by the AT&T. And the lead people here was Ken Thompson and Dennis Ritchie. So they started the project, but that didn't go well. It was the project that they wanted to do in the operating system. And by the way, everything that they were doing, it was in the machine language, right? What is the machine language is nothing but a binary language. So everything before in 1960 or 1950, everything that used to happen was in the binary language, which is 010101, right? You have all this stuff with the zero, and this is the machine language or low level language, we call it. And even to this date, hardware only understand this language, right? So we have a lot of translators. So the programming language that we're talking about, the Python, the Java, the C, the C++, C#, Golang, Ruby, whatever you name it, those are all high level languages which human can easily understand, but machine will always translate that to the low level language, which will be in a binary, and that's what machine understands. So when AT&T lab is actually doing this, they're actually writing everything with this one. So if I want to write, hi, my name is, so this will be converted into binary, because in binary, A is represented maybe with the 001, and B is represented with, this is just an example, right? These are not the correct representation, but just giving you the example. So similarly, so there will be 001, 101, 1010, like four digit, 5 digits, something like that. And that's how I'll be able to then, translate, and I can put some number around it, right? So I can actually write this sentence in the binary language as well. All I need is to find out, okay, what is the binary number for the S, what is the binary number for the H and E and H and Z and D. Again, that way, I can do that. So this is what they were doing. I mean, because that's the only language that machine understands, even to this date. So they were doing everything in the very low language, but that didn't work out for them, and they dumped it. AT&T discontinued the Multix or Multi-CS project, and later, because it was by the whole team of the AT&T lab, and in that team there was two people, Ken Thompson and Dennis Ritchie as well. Later, these people decided to do that project on their own, and they were able to do that. They actually did that, and in 1969 they were able to successfully write the Ken Thompson. Let me put the name, because these are important people. Dennis Ritchie. So they were able to, the project which AT&T as a team could not do that. These two people, they ended up doing it, because around the same time they actually invented the language as well. The C came in and they wanted an operating system. They did that. The whole thing was written in the low language, like a binary language. So you can imagine the amount of effort these people had to put in to come up with this one, right? It's not that easy. I mean, the programming language, if you think that is easy, the high level that we are using, then just imagine how it would have been, how it is actually, how it would have been for these people to write a language like that. So they created an abstracted language as well, the C and C++, and it's not very user friendly that everybody can work. So what they did, they rewrote this whole thing, and in 1970 they rewrote everything, the whole thing into a C language, and they call this UniCS. And this also stands for something else, and later, this becomes a Unix. That's the way they used to pronounce it, and they changed the spelling of this as well, and this becomes Unix like this. So we are calling this Unix the operating system, and this is the mother of operating system from here on, because this was and this is 1970, right? And if you remember, the before 1980, only the hardware had a copyright. So these were not copyright. Since these were now written in C language, which is portable, C is considered to be the high level language. It's not binary anymore. So this was portable language, and from 1970 to the 1980s, people started then they used the Unix, and they created so many different languages. So I'm not going to write that. I have a very good image which I found it from the internet, and which actually shows the whole. Let me get this here. The whole research around this one, right? So you have the Unix research going on here that is happening, started around 1970. I mean, 1970, the Unix were written, right? That's the point I was trying to make. And from here on, the BSD is the one, actually the Berkeley software distribution came in, the operating system. The AIX from the IBM came in. The HP UX and the commercial Unix by the AT&T were also there, because it was hugely inspired by their project, right? And these people were also working. The Ken Thompson and Dennis Ritchie were also working there. And then you have, your Mac OS here, the referencing, and we have the Linux here. We'll see that. And the GNU is also, it's coming and heavily inspired by this one. But if you see for the Linux, right, I brought this image a little earlier, and actually this will help to get an understanding of the Linux as well. So let me, write this down here, or maybe not. Fine. So this guy, Andrew Tanbaum, I mean, he's a professor, and he created his own operating system called Minix, or that was also inspired from the Unix. I mean, pretty much everything that you have, that you can think, the FreeBSD, OpenBSD, the Mac, even there are some theories around the Windows DOS which came around with, that was also heavily inspired by this. There is a very good story about that as well. I'll share one link where, if you guys have not seen it, where how Bill Gates became Bill Gates. The guy who could have been the Bill Gates, he died by suicide because of the depression, because he lost the opportunity which Bill Gates capitalized in. And I mean, it's a very good documentary, a very short documentary, about 10 to 15 minutes, which I would, it's a very informative. You can come to know about what was happening around that era, and it's, it will grab your attention as well. It's interesting. So, I'll share the link. Just somebody remind me. Is there on the YouTube, and you should see that the guy who could have been Bill Gates, and in around 1980s he died by suicide. He was under the depression because he lost the opportunity which he could have had it. So the operating system which Bill Gates actually sold to IBM, because this is where it all started. IBM was the hardware company; they didn't have operating system, and Apple was just dominating the whole, on its own. But there was one problem with the Apple, that they were not actually buying someone else's hardware. Apple had this thing that it will be our hardware and it will be our software. You cannot customize, like buy hardware from the IBM or HP and then bring my software and run it there. Apple didn't allow that. And IBM wanted to compete that, because IBM have always been a big name in the IT infrastructure. They've always participated in everything that has happened in the IT. So they wanted an operating system as well. So instead of writing by their own, they actually wanted to buy it from the guy, from that person. But that person he somehow missed the opportunity. So something you can go and see that. And then IBM actually went to Bill Gates, and Bill Gates sold the pirated version of whatever that guy has built, which was also inspired from the Unix. So I forgot the name of the guy who could have been the Bill Gates. That's the title of the documentary. That guy actually created an operating system which was also inspired by the Unix, and Bill Gates had a pirated version of that person, whatever he created. He sold it to IBM. They signed up a $1 million deal, and that's the journey for the Bill Gates. From there on started. So anyway, coming back to our topic, which is Linux here. So the GNU movement happened around 83, 87, right? It was started 83, and by the 87, it was stabilized. And the Minix, so the Linux is a combination of Unix, Minix, and because it was created by a guy called, so it was Unix plus Minix equal to Linux, right? And the reason why it was named Linux because of his name. His name was Linus Torvald. So he is the guy who actually, he was writing a kernel to support the GNU project because they had software, but they didn't have the kernel that would go on to a former operating system. So he was just for a hobby. He started writing it. He actually did a lot of study for the Minix. So it's mostly inspired or has a lot of similarity from the Minix, not from the Unix, but Minix itself is, inspired, or it is actually referenced to the Unix, right? It's coming from the Unix. This Professor Andrew Tannenbaum, the guy who actually wrote this. So Linus Torvald was one of the students of that professor, and he used to follow him. And he ended up creating a Linux just as a hobby. And he actually named it as a FreeX, something like that. But one of his friends changed that name to Linux because it was more similar, and it matched with his name as well. So you had Unix, Minix, and Linux. And right now, this is pronounced, there are different variation of pronunciations, right? Some people call Linux, some people will call Linux. I mean, people in the States, right? They have a habit of pronouncing I as a I. They don't pronounce I as a E. But in one of the interview, Linus Torvald said the guy who actually was responsible for putting this on the FTP server so everybody can access it, he named it Linux, and they decided, and they used to call it Linux, and that's what he said people should also call it. Even his name, the pronunciation, he's a Swedish guy, and the pronunciation for his name is Eunice, right? Because in Swedish this is pronounced as a Y. So people call him Linus, and back home, I think he's in a Helsinki. So he's a Greek guy. He's not a Swedish guy. Sorry. So his actual pronunciation for his name is Yunus, and he's least bothered about pronunciation of his name. But he is actually asking people to call this Linux. Don't call it Linux or Linux or Linux. Linux. But you'll hear based on which people you are interacting with, you'll hear a different variation of the pronunciation. Right. So, so that's the history of the Linux. But the big question is Linux an operating system? People call Linux an operating system, but technically that's not right. Technically that is wrong. Linux is not an operating system. Linux is the kernel. So Linux is your kernel. It's not an operating system. What is operating system? The software, the GNU software, or in Linux world, we'll avoid calling it software because we call them applications. The GNU application and Linux kernel, they make up for the operating system. Right? That's always. So you have a hardware, you have GNU, you have kernel, you have application. I mean, you have hardware, kernel, and application. Now you have yourself an operating system, and then there are improvements, which I showed you, which current. I mean, you're gonna have this kernel, software, and software manager. And if this is a server, then you're gonna have this bit. If this is a desktop, then you're gonna have all four as a part of your operating system. Today, there are there are like thousands, there are thousands, if not 100,000 different operating systems from the Linux available. And there are different terms as well that we use. We call them a flavor. You'll hear people calling a distro. So, so there are different flavors of Linux because Linux is the kernel, and actually saying Linux as a Linux is the operating system is not wrong, because that's how dominant it has been, and it has changed the whole IT industry or the infrastructure industry. Linux server side, Linux operate about 90% servers. The enterprise servers where people do actual business is the type Linux type. It's not a Windows or it's not a Mac. Right? You have all Linux servers because they are robust. They have a lot of security. They have a very good network integration. I mean, there are so many benefits you have, and it's easy to use as well. A less resource consumption compared to the other operating systems which are available, and that's why they are so popular. And that's the reason why everybody uses Linux as the operating system for hosting their application, which are running on the production, right? So in Linux we have different flavors and we have different distribution. So distribution is basically shortened to distro. So you'll hear people talk about Linux distro, Linux. It's coming from the and there is a family as well. And so these are the few typical name that you'll hear people are actually referencing for the Linux. They probably call Linux distro is very common, and actually it sounds very cool as well. And you'll hear people talking about Linux distro. They might call different flavors of Linux, or they belong to different family of the Linux. So I'll show you the family tree for the Linux, and it is actually quite overwhelming when we see that. So before we actually go and see that, there are few major families that I would like to write it down here, and the chances are very high that you're gonna come across those. So the first one is the Red Hat. There is the Red Hat family. It was started by some person. I don't again remember the name because he's not that important, at least for us to know. But you wanna be a historian, right? You may wanna remember his name. You can always look up on the internet and you'll find it. So he started a company called Red Hat, and he ended up convincing Linus Torvald to work here in his company. And when he actually worked there, then Red Hat has simply dominated ever since. Because Linus Torvald is the creator of Linux, and he himself is working here. So you have the founder, the creator, the manufacturer itself working here. Then you go that. So I mean, on the stock market, when they actually went public, when they published their stock to the exchange, it went to a very sky high, from the day one, something like that. So point here was they convinced Linus to work with them, and Linus Torvald is working. So Red Hat is the major family, or Red Hat is the first who actually started with the enterprise one. The whole Linux thing is actually coming part of the GNU movement, where you don't talk about enterprise. You're talking about free software. You're talking about the free service, a community help. You don't talk about enterprise, but he created enterprise because he knew that. And by the way, when they were fighting, right, this Linus the Richard Stallman and the other the propriety holders of the software, like Bill Gates, Steve Jobs, the IBM owners, the HP, and other companies, when they were actually up against Richard Stallman's free movement, they made a very good point by saying, we are not just selling you the software, we are actually selling you the service as well. Who's going to support you, right? That's what the rationale to all the big companies, because if I mean, they are the threat, right? For all these people who are actually selling the software and earning them, they actually became a threat for all of these companies, the enterprise proprietary software sellers. So they were they started convincing, politicizing as well. If you take a free software, then who's going to support you? I mean, your production application goes down in the middle of the night. The community is not going to be up for you, because community will be there whenever they want. You can't get a timely support. And how do you run that? How do you run that your business? How do you tell your stakeholder? How do you tell your customer that, okay, if customer raises the same question, what would you do if the application goes down in the middle of the night? How do you plan to bring it back? So without software, without the expert people of the maker, you have no chance of actually convincing your own customer that you're gonna do something like that. So they came up with that. Bill Gates made that statement that we are not selling you just the software, but we are giving you the support and the service as well, right? And that is the timely support that we are giving you. So anything goes down anytime, we are there to help you. We are there at your service. So, and that's actually matter for us as well. Whenever we buy a cell phone, a mobile phone or a laptop, I don't know what you guys think, but here in India, people they want to know what is the where is the service center, how fast or how quickly I can, if something goes wrong, because that's bound to happen. If I bought a mobile phone and that can get damaged, it can get faulty, it may stop working. Where is the support service center where I can go and get it repaired? So how quickly and how feasible it is for me to go there? If Samsung has a store around me, then I'm gonna go and buy that because it's feasible. If Apple has a store around me, I'm gonna go do that. And same goes with the other cell phones as well. So we always have that tendency. Okay, we bought the product, but what after that? There is a life cycle to that product, and how do I make sure that life cycle goes the way the way that not gonna bother me much, right? That things that won't give me a sleepless night. So that was their argument against this, and this fella created an enterprise with the same argument because he knew that people gonna be needing it now. Everybody started using it. Let me start selling this as an enterprise, and he created with the Red Hat, and which is known as Red Hat Enterprise Linux. And Linus, he was working there until 2020. We then left it. But anyway, so this is one of the major family. And within that, the few that you wanna know is the Fedora. Fedora is also coming from, so Fedora distribution is coming from the Red Hat family. So we have Fedora, and another one we have is CentOS, which is the exact replica of the Red Hat. So out of 90% that corporate or companies that uses Linux, out of that, around 80 to 70% of the companies uses Red Hat, right? Or at least, I would put it this way: all the companies who are mid-sized to large company to Fortune 1000 and Fortune 500 companies, they all use Red Hat. Every company using a Red Hat. If you are a startup company, if you do not have a lot of finance, you don't have money, then you go with someone else. But everybody pretty much are using Red Hat, because Red Hat gives you a support, and Red Hat actually works quite well. So the focus here was on security and the reliability of the operating system along with the service, and it was designed for the enterprise or business use, right? So and Red Hat made a lot of sales. But the other problem is, if Red Hat, you have to pay for it, and as a company, you're gonna need a people that can work on this, right? Because that's important. If you don't have a skillful people, there is no point for you to go and get that particular service, because you as a owner not going to be working on that. So you wanna go for something which is the skills which are available in the market. So people who wants to learn the Red Hat, students, they don't have a lot of money. They can't go and buy these licenses which cost fortunes. They don't have that money. So how do students learn Red Hat so they can actually go in some companies and do some work? So this is the way they can do that. And this CentOS project is funded by Red Hat. So again, the open source thing, one of the benefit, the community is contributing, they're bringing a new feature and they're testing it. Once it's tested, once it's finalized, Red Hat is just simply gonna take that feature. Okay, let me get this and let me introduce to the to my RHEL version of whatever that I'm releasing. So that's how they do that, and that's the reason why they are funding and they keep this running. But recently there have been some dispute, and Red Hat discontinued CentOS, and all the people who are actually using CentOS in the production, they actually got worried. And another operating system has came up is the Rocky OS now, which is is actually fork of the CentOS. So it is also in the same family tree. The other one, other family or the major family that we have other than Red Hat is Debian. And Debian has a very good history. There was this guy called Ian something, I forgot his last name. I know his name because actually the name is written here. His name is written here. And Debian has a very good, it's actually the name of his wife, Deborah plus Ian. And that's how it became, So because he created this, the Linux kernel is available for you to use. So pick a Linux kernel, write few software, maybe add some functionality, and you have yourself your operating system. I'll show you how you can create your own operating system as well. There is a project called Linux from scratch, LFS. Right. So I'll show you a few links which are gonna help you understand more about Linux. But let's just talk about the families. So then we'll visit to those links as a closing notes. So you have a Debian, and a Debian has another interesting fact about them is Debian operating. I mean, all these operating system had some code name. So you have you have some versions. Along with that, you have some code name as well to them. So you're gonna have a version 5, but that version 5 gonna have some code name as well. Version 6 had some code name. Here, Ian was a very he was a very fan or fond of Toy Story. So all of the versions that they have created is some character of the Toy Story movie or Toy Story novel, whatever they have. So the first one was Buzz, which was version 1.0, and currently so 2, 3, 4, 5, 6, 9, and I think right now the version 10 is being used, and the name of that, I think name which is Buster, I think, and that is the version 10. And so that's different versions, and it's all Toy Story characters that they have. So from here, there are few, from this family, or from, this is family, and these are the members that I'm writing now. Ubuntu is very popular, and it's a very operating system that everybody would recommend you to get started with, because it is a multi-purpose operating system, and it is very easy for people to get started with. So most of the people will recommend you to do that. And Ubuntu project is actually created by a British company called Canonical, and they've also started giving enterprise version of the Ubuntu as well. So the company name is Canonical, which is, and within that Ubuntu, there are different variations out there, and I'm gonna write this name. You might find those funny, but I mean that's actually the name. So they have Ubuntu, they have Xubuntu. I mean, because these are all the different variations, and they have Lubuntu, and I think, I'm not sure if there is a Kubuntu, but let me just write down. I mean, you have like 5 different variations within the Ubuntu, right? And they are just different look and feature. They've added a different graphics to the UI. They've added different packages, different. But Linux kernel, they're all coming from the Linux kernel. The another one from the Debian family is I think from which is a Kali Linux, which is very popularly known or popularly used for the from the security testing point of view. Ethical hacking, you want to do some penetration testing or any sort of in the Kali Linux, you have everything out of the box. All the tools, all the hacking tools are available. So all the people that you see in the movie, right, they carry some kind of a device or something, or they have nothing but a Kali Linux. All the different tools that are available for a hackers. You want to do any kind of a hacking, you want to do a password cracking, a DDoS attack, or you want to do some kind of a poison man in the middle attack. Or there are different tools that can help you do that cross-site. So all the tools are actually here. So it is a heaven for the hackers. I mean, you have it, and if you are doing ethical hacking, which is the white hat hacking, a very ethical way to do that, right? So you'll work on the on that, and it is also coming from the Debian, right? And and actually, Kali Linux previously it was known as Backtrack Linux, because that's normally hacking is normally you are backtracking it. You are doing a reverse engineering of the software that are created, and if you do it with permission, then that becomes ethical. If you do without permission, then that's become a black. There are white hat hacker and black hat hackers. Black hat hackers are the one who have malicious intent, who do not have a proper authorization, and they are doing that. So that's that's a different type of hackings you have. There is another one called SUSE. The reason why I'm writing these names, because these are the popular operating system names that you'll come across, and these are the ones that I'm writing because they have an enterprise version. In SUSE, I mean, it started from the Slackware, and right now there is an Open and SUSE Enterprise. SUSE is just an enterprise, and then there's OpenSUSE. And OpenSUSE and SUSE Enterprise, I mean, I think E stands for enterprise anyway. I don't know. It's the same concept between Red Hat and CentOS, right? So it's coming from the SUSE family, and there are. I'm just writing the top ones, right? I'm going to show you the amount of different variation or different distros that are coming out of these, right? Just in a moment. So now is the time that I'm going to take you to the links where you can actually see and get overwhelmed by the numbers of different distributions are there. So these are the few operating systems which are used by the corporations, by the companies, and there are high chances that you'll also come across these. From the server point of view, you either going to be working on the Debian server, CentOS server, Red Hat, or SUSE, and that's I think that's about it. I don't think you will be able to use some other servers that are there. And Kali Linux, in case if you are doing some kind of a security, because you have all the different applications available here. I think among all this, Red Hat is like 70% dominated, and Debian and Ubuntu are also have some share, and SUSE have started using it because this is a very recent project. I think somewhere started somewhere around 2016. So that's the history about it. So, but SUSE Enterprise is also is more efficient and more optimized compared to the other ones that are there. Plus, it has the very good security and very user friendly as well. That's what that's the thing about it. So you may come across a company or a project where they might be using SUSE, they might be using Ubuntu or Debian or Red Hat or CentOS, based on that. So that's the case. So now let's go and look at the different distros that are available. The different flavors are there. So there is this one link on the Wikipedia, which actually does a very good job of representing it, and pretty much everybody uses that. So I'm going to write Linux distribution. We go back to the link. So let me open this up and let's zoom it. So you can see the Slackware. I mean, this is the major family, and from the Slackware, the different operating systems that are coming, the MNIS, the Stampede, Vector Linux, WAG, Slam. I mean, you can just it doesn't even fit in a one image, right? It's a pretty huge image. Then you have this one, a Debian family, and from the Debian family, these are the different flavors you have within that, right? So it's quite overwhelming, and again, these are all the top ones that are there. I'll show you the Ubuntu that is coming probably from Ubuntu somewhere here. So from the Ubuntu as well, there are so many forks. Ubuntu itself is a fork of the Debian, and you have so many that are there. And then somewhere here down the line will be Red Hat as well. This is coming from the Debian. I mean, it's quite huge. You can actually go and take a good look at that. And it has a timeline as well. You can see that. So these many, and there are actually even more. These are just the ones which are popular, and they have some use case, good use cases. But then there are so many ones that are not that popular, and that's why it's not available in this image right now. Or Wikipedia has not deemed them to be worthy of putting into this picture, and they will have their fair reasons why they don't have. So you can, if you want to do that as well. Now you know how to create an operating system. You need a bunch of software, which you can always get it from the open source platform, right? You can take it from the Gnu, CNCF, Apache, and then there are so many different foundations as well. You have a bunch of softwares. You have the Linux kernel as well. You can just combine kernel with the software and add few tweaks and turns here and there, and you have your operating system if you want to create it. So if you want to learn creating an operating system, so there is another project called LFS, Linux from scratch, and it is also organization. And if you come here, they will actually gonna guide you about how you can go and create your own operating system, and from the kernel point of view, what things you need to know and how it can be developed or how it can be built. Right? So you can read about it. There are so many. I mean, there are so many learning materials on the YouTube itself that people have actually spent They've uploaded 16 hours, 10 hours videos where they've actually did a Linux from the scratch. They've created their own. That will give you a lot of understanding about what goes beneath the one. We may not be working on the kernel because we are not going into kernel development. So I won't be showing you a kernel development. I'll be showing you from the administration perspective, like what things you want to do on top of that. But if you want to understand beneath that, you could do that, right? And this will actually take your understanding to a next level. Probably you'll be amongst definitely you want to be amongst the elite if you have done this, even if you have done the halfway. All right. So all these big university, the people, they actually do this. Right, all the big names, the colleges and the university and the schools, there they actually ask people to do that. And this is where you have these creative people who are, even they are school dropout, college dropout, they still go on to become multi-million people. How does that happen? Because from the day one they have been given that kind of education. They know a lot of resources, and all they have to do is do the mix and match and apply some idea, use the and come up with some new product. So it's easy said than done, right? I know all of this stuff, but I'm not amongst the elite, right now. At least I have some level of understanding, but I'm trying to encourage people here. Maybe not all of you, but even one of the person would go. That would be a good thing to know. I mean, I also try to do that, but I'm not that level yet, and hopefully I'll go on to do something at some point of time. That's like my future desire that I have, or goal. Okay, so another one where from the wiki that the operating system are not reported. Actually, there is a very good site called DistroWatch where you can go. So once you create your own operating system, how do you let the world know, right? So this is the place where you can actually publish your operating system. So anytime you create your operating system following the LFS project, you come here and publish it, right? And there is a whole thing that is written. How do you do that? And here is the distro, each of the different versions of the Linux coming up, all listed here. The ones which are recent or popular with the the description, what this is about and what this gonna do that, and more information. You can always follow the project, like there is a link beneath. All the projects are there. So DistroWatch is the place where you can publish, or if you just want to see what are the new operating systems that have come within this, you can see that as well. Right. So that's about the Linux history, and what is the Linux as well. Right now, I hope everybody knows what is the Linux. Linux is the kernel, but if you're calling it as an operating system, is not wrong, but technically that's not right. Right nowadays, it has been used very frequently or very interchangeably. That even if you were to go ahead and say that, that's fine. But Linux have never been an operating system. It's a kernel. What are the operating system then? These are the operating system. What makes up for the operating system? The kernel, the software, the package manager. We'll actually gonna look a very good. We'll look into a very good detail about the different package managers. We'll start practicals hopefully from tomorrow. I mean, there are few more things that we want to cover, and theories are important, and I'm trying to make it as interesting as possible for you guys, so you don't lose your you don't get bored to death, right? I don't want to do that. I know practicals are something excites everyone, but theories are also important. So just hold on for a day, maybe another lecture, and then we'll be doing a lot of stuff on the on the lab, and there as well, because you might be having a habit of doing everything from the graphics, but now you're gonna have to do this from the kernel. And on the kernel, when everything, you have all this black and white stuff, and your head will start spinning if you don't know what's happening there. So we'll try to keep a graphics along with the terminal as well. So when we do a lot of stuff, your head don't spin, because if you are new and you don't know what's happening, you're gonna lose interest, and you just watch it for a few minutes, your head will start spinning as well, because that's normally happens. It happens with me as well at time. So that's normal. Just try to understand, because once you understand the terminal, right, you're gonna fall in love with that. You don't want to do that anything from the UI, because what the benefit of that is. So let's talk about the kernel, right, and why you want to do that. So you have all your resources. By the way, the resource for us, for this, there are three main resources we have. We have computing resources, which are RAM and CPU. Then we have storage. I mean, I like to write this again and again and again, because it is very important, and you should know that as well. You should just memorize it, maybe scram it if you want, but you should know. Even if I were to wake up you in the middle of the night and I ask you what are the resources for the infrastructure, the important resources, you should be able to tell me these four things that I'm writing here. Storage, and then we have the NIC. NIC is the network card, right? NIC is the one who's going to give you the identity. People understand what are the RAM, people understand CPU, storage, but they start scratching their head as soon as I write NIC. NIC is the network card, and if you want to imagine, this is the guy who's actually responsible for giving you the identity. Without this, you don't have any identity. On the network, nobody can find you, nobody can talk to you. If you want to be social on the network, right, talk to the other computers, have a chat with them, you want to have a NIC, because this guy will give you the identity and you'll be accepted in the network world, right? That's what this is going to do. So network interface card is the one who will give you the identity, and you'll be able to go outside of your house, talk to other people, exchange information, do all sort of good stuff. So let me get these resources. Put some color to this. RAM, disk, NIC, network, and then we have CPU. Right, these are the four resources, and then there will be additionals. If you are doing, I mean, nowadays you have GPUs, you have different cards, right, different converters, different audio video devices. So those are all your hardwares, right? Those are like luxurious needs. So you have a basic need, right? A human has a basic need, which is to food, clothes, and shelter. And then you have a luxurious need where you want to have in a big house, you want to own a car, you want to have a swimming pool, you want to have a fancy clothes. Those are the luxurious needs. Those are not the need to survive. To survive, you need food, clothes, and shelter. That's considered to be the basic needs. So this is the operating system, and operating system is, and the guy who's actually responsible that will allow you to talk to all of these hardware is this kernel thing. So as a part of your operating system, you have kernels and all the basic application. And on top of that basic application, you have, you can have your actual applications, like whatever program that you have written, and you can have your bunch of applications as well. So that's the typical layout of the operating system. We can have our application here. So kernels are just bunch of drivers that are connecting the drivers. I mean, these are the drivers that is connecting you to all the resources, right? And if you send a signal here, this will go to operating system. Operating system will convey that to kernel, and kernel will then convey that to actual hardware. So if you want to use, if you have a memory intensive memory intensive application and you want to use more memory to process that particular thing, you're gonna send that signal to operating system. Operating system will send that to through with the help of kernel. It will be communicated to the RAM, and then you will be allocated more space in the RAM. So to do your work, if you need a if you need CPU, if you want to increase the volume, it's the same thing, right? So that's that's the job of the kernel. So kernel is just the mediator who's actually connecting you to the hardwares that are there operating, and it's part of the operating system, and you're gonna have that. So Linux is the kernel, which will be sold with the different distributions that we have. All right, I think with that, mostly from the theory point of view, we are done. We just need to do a little comparison before we start the lab. Something, we'll take it tomorrow. And yeah, so let's wrap it up for the day, and I'll open a floor for a few minutes for the question answer. So if anybody have any question, any doubt, any confusion, any query, like anything, you can just throw it at me right now. This is your chance, and I'll try to answer that. And if I don't have the answer, then I'll come back with the answer later.